This is Babitha, working as Assistant Professor in the Department of Electronics and Communication Engineering, Institute of Aeronautical Engineering. Today I am going to discuss about different types of clipping circuits. So, before going to the clipper, first of all, we have to know what are the contents we are going to discuss in this session. That is, I'm going to discuss what is meant by clipper and what are the different types of clippers and where we can use these particular types of clippers. So here what is meant by clipper? So clipper is a circuit which is used to remove or clip some portion of the waveform, and while performing this clipping operation it should not disturb the remaining portion of the waveform. So that is the basic function of the clipper. It will remove the unwanted portion of the signal, and while doing the clipping operation it should not disturb the remaining portion of the waveform. So that is the basic function of the clipper here. So these clippers are also called as limiters and slicers, and we can also call it as wave shaping circuits. And where we can use this particular clippers? These clippers we can use for wave shaping as well as in order to remove the noise from the desired signal. In that particular application, we can use clippers. For example, I can consider one signal. I'm considering one signal, and this signal I'm sending from transmitter to receiver through the channel. Transmitter to receiver through the channel. So across the receiver, I am getting the signal like this with some noise. That is nothing but when we are sending the signal from transmitter to receiver through the proper communication channel, because of any effects, that is due to the environmental effects or due to the channel effects or due to the component effects in the circuit, we may get noise across the output of the signal across the receiver. So we have to remove that noise and we require our desired signal. So in order to remove that noise from the desired signal, we can utilize the clipper circuit here. So I am giving this received signal to my clipper. So this clipper will remove the unwanted part, that is noise content, from the output, and it will provide the without noise signal as my output. Okay, but while performing this operation or this clipping operation, the amplitude of my signal is reducing. So my signal is weaker now. So in order to improve the strength of my signal, again I am applying this clipping output to the amplifier circuit. This is the V0 from the clipper. This signal I am applying to the amplifier. Then across the output of the amplifier, I will get the amplified signal. That is nothing but the amplitude of the signal is increasing and my output signal is strengthened now. So in this particular application, we can use the clipper in order to remove the noise from the desired signal in the communication system. So this is the main as well as basic requirement and function of the clipper here. So these are the some clippers we can observe on the screen. So this is the robotic type nail cutter. It will remove the nails, those are unwanted to us. And we can also observe normal nail cutter and remaining pictures. These all are the live examples of the clipping circuits. This will remove our unwanted contents. So next we will see the different classifications of the clippers. So in the clipper circuits, we are having two types: series clipper circuits and shunt clipper circuits. So in the case of series clipper circuits, again we are having positive clippers as well as negative clippers. In the positive clippers, we are having series positive clipper circuit, and also we are having series positive clipper with positive biasing, and as well as series positive clipper with negative biasing. And similarly, in the case of series negative clipper circuit, we are also having series negative clipper with positive bias as well as series negative clipper with negative bias. Similarly, in the case of shunt clippers also, we are having both the positive and negative clippers. So in the shunt positive clippers also, we are having shunt positive with positive biasing and shunt positive with negative biasing circuits. And similarly, in the shunt negative clipping circuits also, we are having shunt positive biasing circuit as well as shunt negative with negative biasing circuit. So these are the different types of clipper circuits we are going to discuss in this session. So before going to discuss the classification of clippers, first of all, we have to know how to construct the basic clipper here. So to construct the clipper, we require two components here. One is the diode and one is the resistor. So why? Because here clipper is the one of the basic application of the PN junction diode. So that's why we are going to utilize the diode to design the any type of clipper circuit. So how we can differentiate whether the given clipper is series clipper or shunt clipper means depends upon the construction here. If the diode is in series with the resistor, then we can call it as the series clipper. If the diode is in shunt with the resistor or parallel with the resistor, we can call it as the shunt clipper. So our first type of clipper is the series positive clipper circuit. So this is the circuit of the series positive clipper circuit. Here we can observe both the diode as well as resistor are in series. So in order to see the operation of this clipper, first of all we have to know the operation of the PN junction diode. So when we apply the forward bias to PN junction diode, it acts like a closed switch and it entered into the forward bias condition and voltage pass through it. And similarly, when we provide the reverse bias to the diode, then it will enter into the off state and it acts like a open switch and it does not allow any voltage through it as well as current. So this is the basic operation of the diode we know already. What is meant by positive bias and negative bias means when we provide the similar polarities, then we can say it as the positive bias, and when we can apply the opposite polarities of your battery terminal to your device, then we can say it as negative bias. Okay. So here, in order to see the operation of this series positive clipper circuit, I am considering first my input signal, that is sinusoidal signal, with the positive amplitude plus Vm and the negative amplitude minus Vm. I am representing it with Vi. Okay, this is my input voltage. So here I am taking first positive half cycle of my input signal in order to see the operation of this positive clipper. So when we apply the positive half cycle to this series positive clipping circuit, what will happen here means this is the cathode terminal of the diode and this is the anode terminal of the diode. So for the cathode terminal of the diode, we are providing the positive voltage plus Vm here so that our diode will enter into the reverse bias condition and it acts like a open circuit. So it acts like a open circuit now. So the diode is in open. So once the diode is open means there is no signal pass through the resistor R here. So there is no signal will pass through the resistor R. So my output voltage during the positive half cycle is 0 volts. And similarly, if I apply the negative half cycle of my input voltage to this positive series clipper, in this case, for the cathode terminal of the diode, we are providing the negative voltage. That is nothing but diode will enter into the forward bias condition, so it acts like a short circuit. So the voltage will flow through the load resistance RL and the current will flow through the circuit. So in this case, how much output voltage I am getting here, it is depends upon how much input voltage I am providing to my circuit, that is VI. What is my VI value here? Minus Vm. So this minus Vm as the output voltage during the negative half cycle, I can expect at the output. So this is the output waveform of the series positive clipper. For the positive half cycle, output voltage is 0. So that's why we are indicating with 0. And during the negative half cycle, our output is minus Vm. So that's why we are indicating with minus Vm. So the name itself indicating positive clipper means it will clips the positive portion of our applied signal and it will passes the negative portion of our applied signal. Positive clipper means it clips off the positive portion of our applied signal. And next kind of clipper is series negative clipper. So this is the circuit for series negative clipper. And here also both the diode and resistor are in series. So in order to see the operation of this series negative clipper, again I am considering my input voltage Vi in that positive half cycle from 0 to T by 2. If I apply my positive half cycle of input to the circuit, here this is the anode terminal of the diode, this is the cathode terminal of the diode. So here it is positive, here it is negative. So once it is positive means for the anode terminal we are providing the positive voltage and for the cathode terminal we are providing the negative voltage. So that we are providing same polarities for the same terminals. Anode means positive for the positive terminal of the PN junction diode. Here anode means P type of material, cathode means N type of material. So for the P type of material we are providing the positive voltage and for the N type of material we are providing the negative voltage. So that our diode is in forward bias condition now. So diode is in on state and it is in forward bias condition. So once it is forward bias means the voltage will pass through the diode and the same will appear across the load resistor R. And there is no voltage drop across the resistor diode here. So the total output voltage we will be getting here as Vi, that is equal to plus Vm. So you can see on the output waveform from 0 to T by 2 we are getting the output as plus Vm. And similarly, if I apply the negative half cycle of my input voltage at this time, here it is minus, here it is plus. That is nothing but for the anode terminal of the diode we are providing the negative voltage and for the cathode terminal of the diode we are providing the positive voltage. So reverse polarity we are applying. So the diode will enter into the reverse bias condition. So it acts like a off switch now. So once it is off means the voltage, the total applied voltage will drop across the diode here. So the total voltage is dropping across the diode. So there is no signal pass through the resistor R. That's why the output voltage V0 equal to 0. So that's why from T by 2 T duration, my output is 0 across the output. So the name itself indicating it is series negative clipper. Series means both the diodes and resistor are in series, and negative clipper means it is removing the negative portion of the applied input waveform. So that's why it is named as series negative clipper. And next kind of clipper is series positive clipper with biasing. So till now what we discussed is we remove total positive portion of our applied input signal or negative portion of our applied input signal. Instead of like that, if I wanted to remove only some amount of positive portion of my input signal, at the time I can utilize this kind of clippers, series positive clippers with bias. By using this particular clippers, I can able to remove only some portion of my input waveform. So here we are having two types of series positive clipper with biasing. In that, first one is series positive clipper circuit with positive bias and series positive clipper circuit with negative bias. That is nothing but how we can make this series positive clipper with bias means for the series positive clipper just we need to add one battery to make the clipper with biasing circuit. Already we have series positive clipper as well as series negative clipper. So in the series positive clipper we have both the diode and resistor are in series, and along with the diode and resistor we need to add one more battery to make it as series positive clipper with positive bias as well as negative bias. So in this first I'm going to discuss about series positive clipper circuit with positive bias. So you can observe the circuit diagram here. This diode and resistor already there in the series positive clipper. Just I have added one battery, positive terminal of the battery to the diode and negative terminal to the ground. So that's why it is positive bias. So in order to see the operation of this series positive clipper circuit with positive bias, again I am considering my positive half cycle of my input signal. So when we take the positive half cycle of input signal, that is VM signal plus VM signal, we are applying here. That is nothing but here it is plus, here it is minus. That is nothing but for the cathode terminal of the diode, we are providing the positive voltage. So the positive half cycle of input voltage making the diode into reverse bias condition. Okay, diode making into reverse bias condition. And similarly, what about battery voltage? The battery voltage is positive. It is connected to the anode terminal of the diode. So in this case, the diode will enter into the forward bias condition. So it will on. Okay. So here there is a conflict. One voltage is making the diode forward bias and one voltage is making the diode reverse bias. So how much output voltage we are getting in this case? In order to see that, I have to take two conditions. That is, when our applied input voltage is less than the battery voltage, what is the status of the diode and what is the output voltage? And similarly, when the applied input voltage is greater than the battery voltage, what is the status of the diode and what is the output waveform we are going to get? For that, I am taking if my input voltage is less than the battery voltage. In this case, that is nothing but both the voltages are positive only. Input voltage is positive as well as battery voltage is also positive. But the thing is, for the anode terminal, positive voltage is required, and for the cathode terminal, negative voltage is required to make the diode conduct. But here, for the cathode terminal also, we are providing the positive voltage. So, in this case, if this particular voltage is less than this one means for the anode terminal only we are providing the more positive voltage. So that's why diode will entered into the forward bias condition and it is in on state now. So once the diode is conducting means, okay, once the diode is conducting means there is no drop across the output here. Okay, once the diode is conducting means there is no drop across the diode. So we will get how much battery voltage we are providing here across the output VB. So that we can observe here. V not equal to VB till VA is less than VB. So you can say this is your V. And when the input voltage exceeds the battery voltage, okay, that is nothing but we are providing more positive voltage for the cathode terminal compared to the anode terminal. So at that time, diode is in off state. That is nothing but it will enter into the reverse bias condition. So once it is reverse bias means the total voltage is dropping here. Okay, it is not flows through the output side. So in that case, we will not get any output voltage. That is nothing but here it is dropping to 0. Okay, here it is dropping to 0. And this is the case when we are applying the positive half cycle of the input signal. And similarly, if you take the negative half cycle of the input signal. So if you take the negative half cycle, that is VA is negative now, that is nothing but here it is negative and here it is positive. So for the cathode terminal of the diode, we are providing the negative voltage, and for the anode terminal of the diode, we are providing the positive voltage through the battery. So at this time, so this VA is making the diode into the forward bias condition, and also VB making the diode into forward bias condition. Why? Because for the cathode terminal, we are providing the negative voltage. For the anode terminal, we are providing the positive voltage. So that's why both the voltages are making the diode into the forward bias condition. Okay. So once the diode is in forward bias condition means it will conduct. There is no drop across the diode here. So the total voltage will appear across the resistor R. That is nothing but output voltage equal to input voltage. What is my input voltage here? Minus Vm. So that's why during the negative half cycle, my output is minus Vm. So this is the operation of the series positive clipper with positive bias. So we are using the positive bias, so that's why we can able to clip the positive portion, that is above that battery level portion, we can able to clip by using this particular clipping circuit. And similarly, next kind is series positive clipper with negative bias. So to make this circuit, just we need to flip the battery in the previous circuit so that we can get this particular circuit. Just change the polarities of the battery here. Negative terminal connected to the anode of the diode and the positive terminal should be grounded. So this same we connected reversely in the case of previous circuit. So to see the operation of this series positive clipper with negative bias, again I am considering the positive half cycle of my input signal, that is plus Vm. That is nothing but for the cathode terminal we are providing the positive voltage, and for the anode terminal we are providing the negative voltage for this condition. So in this case, VA is making the diode into reverse bias condition. Why? Because for the cathode positive voltage, and VB is also making the diode into reverse bias. Why? Because for the anode terminal we are providing the negative voltage. So both the input voltage as well as battery voltage are making the diode into non-conducting state. Okay, once the diode is in non-conducting state, means so it will clip the total positive portion of the signal. Why? Because there is no chance of passing the signal from here to here. So it will clip off the total positive portion. But here we are having the battery potential. So how much battery potential is there? That much we will get across the output here. So V naught equal to minus VB. V naught equal to minus VB here. And similarly, if we take for the negative half cycle of my input signal, in this case, here it is negative, here it is positive, and input voltage is making the diode into reverse bias condition and forward bias condition. Input is making the diode to forward bias condition, but the battery voltage is making the diode into reverse bias condition. So once it is reverse bias, one voltage is making it as reverse bias and one voltage is making it as forward bias. Means again we have to consider two conditions: whether input voltage is less than battery voltage, what is the status of the diode, and whether the input voltage is greater than the battery voltage, what is the status of the diode. So if the input voltage is less than the battery voltage, so in this case we will get the diode is in on state. And once the input voltage exceeds the battery voltage, at the time diode will enter into the off state. So once the diode is conducting here, means there is no drop here, it will passing to the signal and to the ground here. At this condition, we will get the output voltage is equal to input voltage, that is equal to minus Vm. So once the input voltage is exceeds the battery voltage, again the diode is in the off state, that is nothing but output equal to 0 volts. That is nothing but during the negative half cycle we are getting the output as minus V, from VB to minus V. If it is exceeds, means again we will get it as VB ohm. And if it is the positive half cycle, we will get it as 0. So next kind of clippers is series negative clipper circuits with biasing. Till now we have seen the series positive clippers with biasing. So now we will see the series negative clipper with positive bias as well as series negative clipper with negative bias. So what is the use of this particular type of clippers here? So series negative clipper with positive bias means it will remove the negative portion, some of the negative portion of our applied input voltage. That is depends upon how much biasing voltage we are providing to our circuit. So in this, first I am going to explain about series negative clipper with positive bias. So here to make the positive series clipper to the negative series clipper, just we have to change the direction of the diode. So the remaining total components are as it is. So to see the operation of this one, again I am considering the positive half cycle of input signal, that is Vi. Here it is plus, here it is minus input voltage. So now we have to see Vi is making the diode into forward bias condition. So it is making the diode into on condition. Okay, and what about VB? VB is making the diode into off condition. Okay, I have already mentioned if one voltage is making the diode into forward bias and one another voltage is making the diode into reverse bias condition, means we have to check once we are applied it, voltage is less than the battery voltage, what will happen? And if the applied voltage is greater than the battery voltage, what will happen? So if input voltage is less than the battery voltage, at that time diode will enter into the off state. Why? Because less positive voltage for the anode terminal compared to the cathode terminal. And if input voltage is greater than VB at that time, the diode is in on state. So once the diode is in off means it is open. So how much output voltage will get? So the total applied voltage is dropping across this diode. So there is no voltage flows through the RL, but the VB voltage is there that we will get across the output. So VB voltage we are getting when VI is less than VB. And when VI is greater than VB, the diode is entered into the forward bias condition. So there is no drop across here. So that's why what is the input voltage you are applying that you can expect across the resistor R. That is nothing but V naught equal to Vi. And what is my Vi? That is equal to Vm. So Vm and get across the output. So similarly, if we see for the negative half cycle of input signal. So in that case, here it is negative, here it is positive. So in this case, my input voltage is making the diode into off state, and the battery voltage is also making the diode into off state. So in this case, both the voltages are making the diode into open circuit means, okay, so total voltage is dropping across the diode only. So no other voltage will appear across the output. So that's why output voltage is equal to 0 volts during the negative half cycle. This 0. And similarly, series negative clipper with negative bias. So here just we have to change the polarities of the battery to make the series negative clipper with negative bias. In the series negative clipper with positive bias circuit, if we change the terminals of the battery, we can get the series negative clipper with negative bias. So here again to see the operation of this one, I am considering the positive half cycle of my input signal. That is, here it is plus for the diode and minus is for cathode terminal of the diode, and the VB is negative voltage is applied to the cathode terminal of the diode. So in this particular case, for the positive half cycle, VI is making the diode into the forward bias condition, so it will enter into the on condition, and VB is making also the diode into on state. So diode is conducting here means there is no drop across the diode, and the total voltage will appear across the output. That is equal to Vi. How much input voltage you are providing, that much appear across the resistor. That is equal to Vi, and Vi value is plus Vm here. So that's why for the positive half cycle, in this case, we are getting the output as plus Vm. And similarly, if we see for the negative half cycle of my input, in that case, here it is minus, here it is plus. So once it is minus means for the anode terminal of the diode, we are providing the negative voltage. So that is nothing but Vi is making the diode into off state. And what about VB? VB is making the diode into on state. So one voltage making the diode on state, and but the input voltage is making the diode into off state. So in this condition, we have to check for input voltage is less than the battery voltage. In this case, if the input voltage is less than the battery voltage means the diode is in off condition. And similarly, if the input voltage exceeds the battery voltage, at the time the diode, here input voltage is less than the battery voltage, that is nothing but diode will enter into the on state, and here it is off state. So once the diode is in on state means it will provide the path here. So once V is less than V, the diode is in on state. So it is flowing the voltage like this. So in this case, the output voltage is VB. How much VB voltage we are providing. So that's why for the negative half cycle, till Vi is less than VB, the output is V. And it will maintain till Vi is less than VB, it will maintain the VB voltage across the output. And once the input voltage exceeds the battery voltage, diode will enter into the off state. So the total applied voltage will drop across this diode only. In this case, the output voltage is 0. So that's why this portion is clipped off. Here it is going to 0. So in the case of series negative clipper with negative bias, we can able to remove the some negative portion of the applied input waveform. And next one is shunt positive clipper circuits. So shunt positive clipper circuits means the diode as well as resistor are in parallel connection here. Till now we have discussed all series clippers only. In that case, both the diode and resistor are in series, but here both are in parallel. So to see the operation of this shunt positive clipper circuit, the clipper may be series one or shunt one, depends upon which type of clipper it will remove that portion. If it is the positive clipper, it will remove the positive portion. If it is negative clipper, it will remove the negative portion of the applied signal. So to see the operation of this one, I am taking my input voltage as plus Vm in the positive direction and minus Vm in the negative direction. First of all, I am considering my positive half cycle of input voltage Vi. If we apply the positive half cycle of input voltage, that is nothing but plus here, minus here. So that is nothing but the positive voltage is applied to the anode terminal of the diode, so that both the polarities are same. The diode is in on state now. So once it is on means there is no drop across this diode, the total voltage will goes to ground here. So that's why the output voltage is 0 during the positive half cycle, that we can observe across the output waveform. This is 0 for the positive half cycle. And similarly, if we apply the negative half cycle of input voltage, that is making the diode into reverse bias condition. Why? Because here it is minus, here it is plus. For the anode terminal of the diode, we are providing the negative voltage. So that's why diode is in off state. So once the diode is in off state means there is no drop across this diode. Okay. So the total applied voltage will appear across the output. That is V0 equal to Vi, and my Vi here it is minus Vi. So that's why during the negative half cycle, my output is minus V. So in the case of shunt positive clipper, it will remove the positive portion of the signal. So next one is shunt negative clipper circuit. So it will remove the negative portion of applied input signal. So again, to see the operation of shunt negative clipper, I am considering the input signal as the sinusoidal signal. In that, I am considering the positive half cycle first. So to make the shunt negative clipper, just we have to reverse the diode direction in the case of shunt positive clipper. Then we will get the shunt negative clipper. So during the positive half cycle, here it is positive and here it is negative. So for the cathode terminal of the diode, we are providing the positive voltage. That is nothing but VI is making the diode into reverse bias condition, that is in off condition. So it is open now. So once it is open means there is all the voltage will drop across the diode here. So that's why once it is open means there is no path to the flow of voltage here. So that's why the applied total voltage will appear across the output. So that's why my output voltage is VI, that is equal to plus VM in this case during the positive half cycle. And similarly, for the negative half cycle of my input signal, here it is minus, here it is plus. In this case, for the cathode terminal of the diode, we are providing the negative voltage so that the diode acts like a closed switch and it is on state now. So once it is on means there is no drop across the diode, so the total voltage will pass to the ground. So in this case the output voltage is 0 volts. So that's why during the negative half cycle my input voltage is 0 here. My output voltage across the clipper is 0 for the negative half cycle. So that is nothing but it is the negative clipper. So that's why it is removed the total negative portion of my applied input waveform. And next, shunt positive clipper with biasing. So in this again we are having two types, shunt positive clipper with positive bias and shunt positive clipper with negative bias. So in this first we are going to discuss about the shunt positive clipper with positive bias. So to make shunt positive clipper with positive bias, we have to add one battery to the shunt positive clipper so that we can make the shunt positive clipper with positive bias. So to see the operation of shunt positive clipper with positive bias, I am considering my input voltage in that first positive half cycle. So for the positive half cycle of my input, in this case VI, the input voltage VI is making the diode into forward bias condition, that is in on condition, and VB, the battery voltage, it is nothing but positive voltage we are applying for the cathode terminal of the diode. So that is making the diode into the reverse bias condition so that it is in off state now. Okay, so again we have to check for two conditions here. Whether the input voltage is less than the battery voltage, what will happen, and if the input voltage is greater than the battery voltage, what will happen. So my input voltage is less than the battery voltage. So at the time the diode will enter into the off state. Why? Because for the anode terminal we are providing less positive voltage compared to the cathode terminal. So that's why it is in off state. But if my input voltage exceeds the battery voltage, that is nothing but for the anode terminal we are providing the more positive voltage compared to the negative terminal, so that the diode will enter into the on state. So once it is off state means, once the diode is in off state means it is open. Keep it is open. How much output voltage I will get here? It is once it is open means there is no chance of signal coming to here. Okay, total voltage is dropping across the open circuited diode. So that's why my output voltage in this case is how much battery voltage I am providing to the circuit, that is VB. The output voltage is VB. So when VI is less than VB, my output is VB. And it will maintain the VB voltage till VI is less than VB. And once my input voltage exceeds the battery voltage, the diode will enter into the on state. Okay, the total signal will goes to ground. So in that case, it will reach to 0 here. So my output voltage is 0 in this case. It is going to 0 when input is greater than the battery voltage. So this is the case for the positive half cycle. And similarly, if we take the negative half cycle of my input voltage. So in this case, here it is negative and here it is positive. So for the anode terminal of the diode, we are providing the input as negative so that the diode is in off state. And similarly, battery voltage is also making diode into reverse bias. Why? Because for the negative terminal of the diode or for the cathode terminal of the diode, we are providing the positive voltage. We are providing the opposite polarity at both the terminals of the diode. So that's why it will enter in reverse bias condition. So once the diode is in reverse bias condition, means it acts like a open circuit. So there is no signal will flow here. The total signal will appear across the output. So V0 is equal to how much input voltage you are providing here, that is Vi. In this case, my Vi is minus Vm. So that's why during the negative half cycle, my output voltage is minus Vm. So from this we can say shunt positive clipper with positive bias will clip the some portion of the positive waveform. That is above the battery voltage, the remaining portion will clip off in the positive direction. And similarly, next one is shunt positive clipper with negative bias. So to make the shunt positive clipper with negative bias, just change the polarity of battery in the shunt positive clipper with positive bias so that we can get this circuit. So to see the analysis of this one, again I am taking my input voltage in that positive half cycle of input voltage. Here it is plus, here it is minus, so that Vi is making the diode into forward bias condition because of positive polarity, and Vb is also making the diode into forward bias condition. It is nothing but the diode is in conduction mode now. So the total voltage is appearing here only. There is no drop across the diode. So in this case, what is my output voltage? What is the battery voltage I am providing? That is my output voltage, that is minus Vb. So during the positive half cycle, my output is minus V. And similarly, for the negative half cycle of my input voltage, that is minus Vm, here it is plus Vm. In that case, here it is minus, here it is plus. That is nothing but, in this case, Vi is making the diode into off state, okay, and Vb is making the diode into on state. So in this case, once the Vi is less than Vm, what will happen? Sorry, Vi is less than battery voltage. What will happen? If the Vi is greater than battery voltage, what will happen? We have to see. Okay, if my input voltage is less than the battery voltage, that is nothing but for the anode terminal we are providing the less negative voltage compared to the cathode terminal, so that the diode will enter into the on state. And similarly, if my input voltage exceeds the battery voltage, that is nothing but anode terminal we are providing more negative voltage. So that's why diode is in off state now. So once the diode is conducting during the Vi is less than Vb, so once it is on, means the output voltage will pass here through the diode to the ground. In this case, my output voltage is V. Okay, my output voltage is V. And once the input voltage exceeds the battery voltage, in that case diode is in off state. At this condition, how much input voltage we are applying, that one will get across the output, that is equal to minus Vm. So Vb to Vm voltage we will expect across the output. So in the case of shunt positive clipper with the negative bias, it will remove the total positive portion of the input waveform and also some portion of the negative signal also. Above the battery level, it is keeping the signal. Below that level, total signal is clipping off. So this is the operation of the shunt positive clipper with negative bias. And next one is shunt negative clipper with biasing circuits. Till now we have seen the shunt positive clippers. So shunt negative clipper circuit with positive bias as well as shunt negative clipper circuit with negative bias we are going to discuss now. So in this case, if you change the direction of the diode, you can able to get the shunt negative clippers. In the case of shunt positive clippers, if you reverse the diode direction, you can make the shunt negative clipper. So to see the operation of this one, again I am considering my input voltage in that positive half cycle. In this, Vi is making the diode into reverse bias condition, it is in off state, and Vb is making the diode into forward bias condition, that is in on state. So some voltage is making the diode in forward bias condition, but the battery voltage is, the input voltage is making the diode into reverse bias condition. So in this case, I'll go with my input voltage is less than the battery voltage, what will happen? And if my input voltage is greater than the battery voltage, what will happen? So if my input voltage is less than the battery voltage, means in this case the diode is in on state. Why? Because for the anode terminal of the diode we are providing the more positive voltage compared to cathode terminal, and for the next case it will be off. Why? Because for the anode terminal we are providing the less voltage. So once the diode is in on state, means it is closed, it is actually like a short circuit. So in this case, my output voltage is how much battery voltage we are providing, that is Vb. Okay, and once my input voltage is exceeding the battery voltage, at the time diode is in open state. So once the diode is open, means the total applied input voltage will appear across the output, that is V0 equal to Vm. So that's why Vm here it is. Okay, and similarly for the negative half cycle of my input voltage, that is minus Vm. So in this case, here it is minus, here it is plus. So for the cathode terminal, we are providing the negative voltage. So Vi is making the diode on and Vb is also making the diode on. So diode is on means it will short. Okay. There is no drop here. So that's why my output voltage is Vb. During the negative half cycle, my output voltage is how much battery voltage I am applying, that is V. So this is the operation of the shunt negative clipper with positive bias. And next we will see the shunt negative clipper with negative bias. Here we have to change the direction of the battery. So again, if you take the positive half cycle of my input voltage, that is equal to plus Vm. So once it is plus Vm, in this case, input is making the diode into reverse bias condition, that is in off state, and also Vb making the diode into off state. So both the voltages are making the diode into open condition. So the total applied voltage will appear across the output, that is Vi is equal to Vm. So for the positive half cycle it is Vm. So similarly for the negative half cycle of my input voltage, that is minus Vm, in this case here it is minus, here it is plus. So for the negative terminal we are providing the negative voltage. It is nothing but it is making the diode into on state, and Vb is making the diode into off state. So in this case again I need to consider the two cases, if Vi is less than Vb and if Vi is greater than Vb, what will happen? If my input voltage is less than the battery voltage, so in this case my diode condition is in off state, and if input voltage exceeds the battery voltage, the status of the diode is in on state. So if it is off means the output voltage is the battery voltage, that is Vb, and if it is exceeds to Vb means the diode is open, and again the output is 0 volts. It will reaches to 0 volts. So this is the operation of the shunt negative clipper with negative bias. So next type of clipper is the dual clipper. Till now we have discussed about all the series and shunt clippers in both the positive and negative types. And the last type is the dual clipper circuit, that is the two-level clipper. So this the function of this two-level clipper is it will remove the some portion of the positive half cycle as well as some portion of the negative half cycle. So if we add both the positive and negative clippers, then we can get the dual clipper or two-level clipper in both the series form as well as shunt form. So to see the operation of this one, I'm taking my input voltage as plus Vm first, that is positive half cycle, Vi equal to plus Vm. In this case, Vi is making the diode is in on state, okay, and Vb1 is making the diode D1 into off state, and similarly Vi is making the diode D2 into off state, and Vb2 is also making the diode into off state. So in this case the D2 is in off state but the D1 is in on state. So it is off means it is open, it is on means it is closed. So this there is no chance of flowing the signal here, but here it is open to till Vb2 it will provide the signal, that is nothing but Vb1. Till Vb1 we will get the output voltage. So in this case the output voltage is Vb. Output voltage is Vb. Okay, and during the positive half cycle again we need to check once the input voltage is less than the Vb1 what will happen, once the input voltage is greater than the Vb1 what will happen. So once the input voltage is less than Vb1 means the diode D1 is in off state and diode D2 is in off state, both are in off state, but Va is greater than Vb1 means diode is in on state. Okay, during the input voltage is greater than Vb1, the diode is in on state. So in this case my output voltage is 0. Here it is 0. So for during the negative half cycle of my input voltage, that is minus Vm, in this case the input voltage is making the diode into off state and D2 is in on state, and similarly the battery voltage Vb2 is making the diode into D1 into off state, but D2 is also in off state. So in this case, once my input voltage is less than the battery voltage, D2 totally in off state, so the output voltage is nothing but my input voltage. And if my input voltage is greater than the battery voltage at the time, D2 is in on state. So once the D2 is in on state means, so there is no signal here. So the output voltage is 0. So it will move to, or it will reach us to 0 here. So this is the operation of the dual clipper circuit. So it will clip the positive portion of the signal as well as some amount of negative portion of the signal here. So this is the output waveform of dual clipper. So this dual clipper, we can also call it as slicer circuit because it is clipping both the positive and negative half cycles. So while coming to the applications of the clippers, here it is, we can use for transmission purpose. We can use basically for transmission purpose and for slicing purpose. And next, in order to remove the noise also, we can use this clipping circuits. So this is about all the types of clippers and its analysis. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.